So we're going to continue our discussion of divisibility. And we're going to talk about this theorem that has to do with factorizing a number. Factorization of integers. So think about a positive integer that's bigger than 1. So for example, let's say we think about the number 50. You can decompose this into a product of primes, right? This is 5 times 10, 5 times 2 times 5, 2 times 5 squared. And anytime you factor it into primes, you would always get the same primes appearing. You would always get a 2 and 2 5s appearing. So this happens in general, not just for this number 50 here, and that's called this unique factorization. So I'm going to write the statement, given an integer n that's at least 1, there exists a positive integer k distinct prime numbers p1, p2 up through pk, and positive integers e1, e2 up through ek, such that n equals p to the e1, p2 to the e2, pk to the ek. So the k is how many distinct primes appear. So in our example with 50, there were 2 distinct primes. P1 would be 2 and P2 would be 5. And then the exponents, these e's, are just how many times they occur when you factor them. So for example, 5 occurred twice when we factored 50. And here's where the unique part comes into play. And any other expression for n as a product of primes is identical except for the order in which the terms appear. So this is just saying that when you factor it into primes, remember multiplication is commutative, so you could rewrite it. So if we look back at our example up here, I could have also written this as 5 squared times 2. So, but it's the same numbers that are appearing, the same prime numbers, but you could write them in a different order if you want to. Okay. So we'd like for there to be one way to write the factorization. So this is the idea behind standard factored form. So here, you're going to decompose your number into these primes, but we're going to require in standard factored form for the primes to be in ascending order. So P1 is smaller than P2 is smaller than PK. So that's how we write things in standard factored form. So let's look at an example. So let's take a number. Let's write 3,300 in standard factored form. So 3,300, there's 2 zeros, which means this is 100 times 33. And then we're going to take and just keep breaking down our factors into prime numbers. So for example, for 100, well, that's 4 times 25. And then 33, that's 3 times 11. And then if I look, the ones that are primes already, 3 and 11 are already prime numbers, so I don't factor those more, but 4 and 25 are not prime. 4 is 2 times 2. 25 is 5 times 5 times 3 times 11. So now we've broken this number down into all of its prime factors. So all we have to do now is write them in ascending order and with exponents. So start with your smallest prime number. My smallest prime number is 2. So it would be 2, and there were 2 factors, so it would be 2 squared. My next smallest prime would be 3. 3, and it only occurred once. Then I had 5. So I would have 5, and then there were 2 of those, so it would be 5 squared. And then finally 11 only occurs once, 11, and the power would be 1. So here we've written the number 3,300 in standard factored form.